we have sigma of an, let's say this is an, so here an, the general term is n factorial over 2 times 5 times 8 all the way to 3n plus 2. Okay, due to this factorial term, we want to use the ratio test. Okay, for that we need the next term, which is an plus 1 next term. Then an plus 1 would be, just replace n by n plus 1, so n plus 1 factorial. Okay, we have a product of n terms. Now an plus 1 means we'll have a product of n plus 1 terms, so we will be adding one more factor. Okay, so 2 times 5 times 8 all the way to 3n plus 2 stays n many times one more factor, which will be just replace n by n plus 1. Let's do over here. So 3n plus 1 plus 2. Okay, replacing n by n plus 1, we get 3n plus 3 plus 2, which is 3n plus 5. So the next factor would be 3n plus 5. Okay, n terms, n factors. Now we'll have n plus 1 factors. Now we take the limit of the ratio, all the positives, so we don't need absolute value. An plus 1 over an, that is the limit of an plus 1, this n plus 1 factorial over 2 times 5 times 8 times all the way to 3n plus 2 times 3n plus 5, that's the an plus 1, divided by an, that means multiply by the reciprocal of an. Okay, let me multiply over there. Divided by an is multiplying by reciprocal of an, which is 2 5 8 all the way to 3n plus 2 divided by n factorial. Okay, when writing an plus 1, the next term, look at these factors, they are adding, we are adding 3 to get the next one. So 3n plus 2, next one 3n plus 2 plus 3, so 3n plus 5. Anyway, we found in the most general way. Let's evaluate this limit. N plus 1 factorial is same as, let me work out here, n plus 1 factorial is the product of n plus 1, 1 less n, 1 less n minus 1 all the way to 3 to 1. If we leave n plus 1 there, then we have now n times 1 less all the way to 1, that is same as n factorial. So n plus 1 factorial is same as n plus 1 times n factorial. Okay, this one is same as n plus 1 times n factorial. How does this help? Then we can cancel n factorial from top and bottom. 2 5 8 all the way to 3n plus 2, 2 5 8 all the way to 3n plus 2. Okay, we can cancel everything from there. Then n plus 1 on the top, 3n plus 5 on the bottom. Okay, let's find this limit. N plus 1 degree 1, 3n plus 1 degree 1, so the leading coefficients 1/3. This limit is 1/3, which is less than 1. Then by the ratio test, the given series converges. By the ratio test, the given series converges. In fact, converges absolutely, but since we got all the positive terms, so just converges is enough.